Alrighty, hello everyone. Thank you for joining me, and sorry for starting late. Tonight, going to work on Advent of Code Day 5. As you can see, I have actually fallen quite far behind. I tried doing Day 5 Monday evening, and this is a case where actually parsing the data and getting it into a useful format was just taking a huge amount of effort. So the problem itself, not really all that interesting. But the actual parsing, that's worthy of a live stream. So, going to jump into this one. Actually, I'm going to turn my music down. There we go. Alrighty. So, as you may remember, Advent of Code, series of problems, 2 problems released every day. Each pair of problems relates to one another. This year, the whole theme is the elves are off on an expedition to recover stars. I have 8 stars so far, so that Santa's sleigh can be powered through the night and can actually deliver presents. We're basically saving Christmas. So the expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. The ship has a giant cargo crane capable of moving crates between stacks. To ensure that none of the crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of the stack. Personally, seems like the kind of thing that should have been done at the beginning before leaving the North Pole, but we wouldn't have a series of challenges if the elves could do everything right on their own. Anyway, the elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crate will end up where, and they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks of the crates and the rearrangement procedure, and this is the puzzle input. Okay, so what we have is a diagram right here, which shows the stacks. The stacks are arranged across horizontally, and then a blank line, and then a series of instructions. And so for this problem, this is a problem of being able to carry out these instructions and figure out what the end result is going to be. So we first need to actually parse all of this stuff. And this is actually unusually difficult. Most Advent of Code problems don't have the parsing step be this challenging. Anyway, for this, I am going to bring in nom parsers. These are a set of combinatorial process parsers for Rust. If you've ever written much in the way of Haskell code, nom parsers are going to feel a lot like parsec. They're pretty much in the same general idea, but the idea is to build small parsers that return data structures for a small portion of the data, and then just slowly build up bigger and bigger parsers until you run a single parser over the entire data. So yeah, that's what we're going to do. As last time, I am going to start out by downloading Rust Analyzer, apparently. Going to start out by adding day 5 to the program. And now we're going to open day 5. Right. Also need to actually import the parsers. already here. Good enough. Yeah. I'll handle the complexities of the import in a few minutes. You have to do a lot of deep imports to use them. Set up some test code. And for the test code, we're just going to start out with the test data that they're providing. Const test data is a string. How did I want to do this? Yeah, we'll keep it simple at the moment. So the very first thing is it can parse the test data. This is actually going to be a pretty big deal all by itself. In fact, I think I want to start with something even simpler, which is it can parse the crates. Nah, that's excessive. What I know from having tried this once before is that I'm going to have two data structures here. One of them is going to be the arrangement, which really is a list of stacks, and the second one is going to be the list of commands. And what I know also is that I want so stacks 0, like the very first stack for this test data, should be I guess maybe a vector of z and m. Maybe. I'm not really sure yet. Okay, something like that. And we're going to expect that there's going to be 3 stacks. Then we're going to expect that there are 4 commands. And in order to write some meaningful tests, I want to actually add the data structure. So struct command is going to be count, and then it's going to be source and destination. And because I'm going to do a comparison in test, Rust really requires that I have at minimum debug, but clone is a good one to have declared on the command. So command 0 should be data structure of count 1, source 2, and dest 1. And instead of being exhaustive, I'm just going to jump all the way to the end here. So the last of the commands, we're going to move 1 from stack number 1 to stack number 2. Should should be noted, is an important detail, would probably trip me up if I didn't pay attention to it. Stacks are 1 indexed, they are not 0 indexed, so whenever I address a stack, I have to keep that in mind. I have to keep in mind to decrement this number in order to match the stack here. Okay, I'm going to save that. I'm going to get the compiler doing its thing. And yeah, lots of problems because I don't actually have everything that's needed yet. We need part 1. Got to make it public. It's not implemented yet. Same with part 2. Okay, and then we need our input function. And I am expecting input to return a vec of type car. No, a vec of cars. And a vec of command. And we're not going to implement that either. Let's just get the compiler working. And use superstar. And all of that. Oh, wow. Oh, right. Command needs to have at least partial EQ defined in order to use it, and in order to do an assertion test. Okay, awesome. Did I really use non-parsers in day 4? Just a moment. Huh. Yes, I did. That's kind of overkill, given what day 4 involved. Okay. So let's start out. My mode of thought is that, so we've got all of this data line by line. In order to make sense of the data, or in order to, like, the unfortunate part of the data being line by line is that I'm reading across the top of all of the stacks, and then across the middle of all of the stacks, and then eventually across the bottom of all of the stacks. And that's not incredibly conducive to being able to manipulate them. I'm going to work with that anyway. My idea here is that when I read this first line, let's go back over to the advent of code. It's formatted a bit better there. When I read this first line, I mean, I think I want to start out by just getting a matrix where, yeah, I don't know. When I read this first line, I'm going to parse out this blank area as a none, and then this area is just a single letter D. For this line, it'll be 2 letters, and then for this line, it'll be 3 letters. I will have to read the final line just to make sure that I know for real how many stacks are going to be present in the final data. If there are any stacks trailing across the end, I won't detect them unless I read this line. So, I want to With a NOM parser, I want to treat each one of these as a separate cell, and the cell can be either a trio of blanks or it can be brackets and a letter. So it's actually best done as two separate parsers. So let's see here. Let's do, I'm going to do like one level higher up and then write the two separate parsers. The definition of a parser needs to be this right here. So input is a string, iResult is a string of, and this string that's part of the result is the remaining unconsumed data in the whole data stream. So we'll do a string, and in this case, I'm going to return if we're going to parse a crate, this is going to be an option car. Going to leave this one unimplemented. So I'm going to write a parser for a space. Actually, yeah. We'll call this one parcel, and then parse crate. Oh, this is actually kind of weird because this is one where I need the two types to match. Maybe that's going a little excessive. I'm going to back up and try to handle the entire cell at once. It's probably a mistake. So let's see here. First of all, start including some of the things from NOM that I'm going to need. So I need iResult. I'm going to use the complete parsers, and I'm going to try to go character based here. So character complete, and then follow it up with what are some of the parsers I need? I'm going to need car, recognize one character. Recognizes 0 or more spaces and tabs. No, I don't want that one. I'm going to stick with just importing car. Yeah. And then I'm going to go back up a level and grab some of the other utilities that I know I'll need, delimiters of various kinds. As soon as I remember where to find them. Combinator. Cut, EOF, flat map, iterator map. All consuming. Delimited. Here we go. Sequence. That's the crate that I want. Gonna save that. Fix some problems. There we go. Of course, it's going to complain that neither of those is being used. Let's see. Gonna go back over to complete. Actually, I'm just gonna look up. Gonna look up tag, like bits, bytes, character, complete, tab, wrong one. tags are like an exact explicit string of characters that you want to match against. I guess we have to use bytes for this, which is a little bit awkward, but fine. Okay. Now we are ready to try parsing the cell. So a cell that has no data in it is going to be it's going to be a tag 1, 2, 3, and it needs to be applied to the input data. And then the result is updated input and a space, basically. And a tag that has some data in it. Or a cell that has some data in it is going to be 3 tags in a row. So it'll be tag, bracket. Actually, it's not 3 tags in a row. It's going to be a tag bracket. It's going to be the car function. Yeah, perfect. Wait, does it want to... Oh, this function wants, I think wants me to specify a character. Recognizes one character. That's not really what I want to use here. Actually, I want any car. Any car takes only the input. Okay, so obviously what I've just written here doesn't precisely work. What I need to do is to start, I need to take these 3 and convert them into a single parser that can work as a unit. And then I need to combine that parser with this one in order to get like try one, then the other. In order to convert these 3 into a unit, I'm going to go back to the sequence parsers. I don't think delimited was the right... Oh yeah, delimited is the correct one. So delimited here takes 3 parsers. The result of the first one and the result of the third one gets discarded, and the result of the second one gets returned. So let's get rid of this, and instead going to combine that. And here are the 3 parameters. Here is a parser that when given input will return an input in a crate. I didn't import any car. What are the complaints? Oh yeah. Do that. Be sure to return if the parser fails. And of course, this whole function is not going to compile because I've got just these 2 random parsers sitting here and I'm not returning any data. So now this is the part that tends to trip me up, because I need to go from these 2 to the combinator. And so here we start looking at the parser trait. Technically a function... Yeah, okay. the parser trait is actually implemented for functions, although that is not necessarily very visible in here. Possibly this one right here. So this function implements the parser trait. This one does not, because I'm not returning an I result. Because it implements the parser trait, though, I have these other utility functions. And the particular one I want to look at right now is the OR function, because it applies the second parser if the first one fails. I mean, that's pretty straightforward. So let input result. Actually, don't even need that. We're going to say let's just delete up to there and delete that, and then just call OR and pass that in. And now here's where it actually gets tricky. The calling convention becomes a bit odd, because although OR operates on a parser, it doesn't return a parser. It returns a different data structure. And this OR data structure, it is an implementation of parser OR. Got it. Okay. So OR is a data structure. It is not necessarily a parser. In order to get back to a parser, we need to explicitly call the parse function. This is a place where NOM kind of breaks pattern. It feels a little bit odd, and so it can be kind of hard to actually track that down. Things become easy as soon as you do track it down. So we're going to save all of that. OR is not found because I neglected to include the trait. The trait is in parser, or in at the top level. Or do I actually do it as self? Maybe not. Okay. Now I have to actually read the error message. Let's flip over to the terminal. Oh boy. Oh boy, this is going to be fun. Okay, mismatch types. Expecting a car found a string. The arguments are incorrect. Huh. Well, it's expecting a result of a particular type. Let's try to factor that out. Error messages from NOM are kind of challenging because of the number of traits that get involved. Start with a clear screen. Try again. Okay. Go to the top. Oh, that is a lot. Okay. So input iter is not implemented for car. That's interesting. Yeah, I'm missing something important. I'm just not sure what it is. There's a variety of places that things may be going wrong. I could be calling this incorrectly, or it could be that it doesn't know because I'm not nailing down exactly what the return type is, that it's angry about that. Oh boy. Live coding, fun stuff. So it's expecting a result, found a tuple. That's easy to fix. There we go. Okay. So, trait bound, error string, parse error car is not satisfied. There is a bound that is required by any car. Okay. So any car, the input has to be t, or it has to be a parse error of t. And it has to be an input iter, input length, slice. And it has to be a car. This type signature is so hard to read. So let's keep that in mind. And then go back to delimited. Delimited has no real constraints, except that the input type has to be the same across all three. All three parsers can return different data, and the output type, excuse me, the output type has to be the same across all three. Okay. Oh, I think I know what it is. Let's grab a third browser window. Go to here and flail about. Okay, keep that in mind. Or requires a parser of a consistent type. I am not being consistent. Because the tag parser here returns a string, and this delimited is going to return a car. That's why it's angry with me. Alrighty. So, let's see here. In order to smash them into the same data type, map a function over the result of a parser. So the first thing I'll do is map this parser. I don't care about the input. I'm just going to return a none. And can you call OR on it? OR is an implement. Is this an implementation of a parser? Maybe. I hope so. And then I need to, somewhere else, I need to map the result. Maybe right here. Yes, I'm sorry, I know I am flailing here. Parse map. Oh yeah, no. It really doesn't like that. Not totally wrong. Okay, so this part is wrong. Let's see if I can nail that down and just narrow down where the problems are. And I'm going to remove some of this. So of course this should fail because map is not a parser. It's parse. Okay, so that parser compiles. Good. Well, some part of it does. It expects a unit structure, unit variant, or unit constant. Found a it's a name. There we go. Good, not being used. Okay. Let's see if this is even a valid way to do things. And then I map this. Yeah, no. Okay, clearly I don't know how to combine parsers correctly. This is a problem that I run into every time I try to use Nom. Okay, this line. Expected a car, found a string. This is going to be weird, but maybe? Wait, nope, not there. Ah, okay. Yeah, no. Cannot combine the types. As soon as I try doing tags across individual characters, it falls apart. So I'll go with strings instead. And you know, a character is just a single letter or a single character string. So we'll save that. That compiled's good. This is obviously going to be wrong for a couple of moments. Let's make sure that I can get this part working. Okay, so far so good. Now we replace this with the catch anything. And that's not correct. So let's see if I can find something that will work. Not delimited instead of any car. Should I sequence something? It's really hard at the moment for me to actually explain what I'm thinking of here. I'm just trying to find gets an object from the first parser, you know, whatever. I can't really use delimited because of the chance that delimited will match like this open bracket, then a whole bunch of these, and then this closed bracket, in which case I only get one result, and I don't like that at all. Man. See, this is why day 5 was particularly hard. The actual solution for the problem is not going to be difficult, but just parsing the data and transforming it, really tough. I feel like this error doesn't even make any sense. So it doesn't want this because of the return type. Tag map. Oh, parse the input. Okay, so that parser works. So this one I can coerce into being an option car. So if I now to map this. What expected it? Ah. Okay, tag just straight up cannot take. Oh. Remember at the very beginning when I talked about the car function? It's like, oh, this matches a single character, and I have to specify the character. Well, I actually need that function here. It will do the same thing for a single character that a tag would do for multiple characters. Great. Okay, now let's combine these two parsers and move on. So, I want to parse a crate dot or. I want to parse a space, and that should be close. Didn't quite do it. Right. There we go. Now I've got a parser that will deal with one cell. Sorry, that's pretty tough. Okay, now let's parse a row. Parse a crate row. How many closing? Let's do that. Okay. So for parse crate row, I want to take, we're taking just one row. So we're going to say that the string is terminated by, make sure to import that. It's going to be terminated by a new line or an end of line. Here we go. First parser to apply, the second parser to match an object. Gets an object from the first parser, then matches an object from the second parser and discards it. So here we actually do want I don't know if we want tag or not, but I want to match against the new line, and then this is going to get more complicated. It's parsing a cell, but parsing it with against something that's separated by spaces. So I'm going to pull up the separated function, separated list, there we go. Alternates between two parsers to produce a list of elements. Here we go. The difference between separated list 0 and separated list 1 is that 0 is allowed to match 0 times, whereas 1 you have to match at least once. It's quite possible that we can, when we're parsing the data, and it's quite possible when parsing the data that we could end up with no matches. Technically, I think that would be just a blank line in the middle of the data, and I don't really expect that to be there, but I'm going to go with it because why not? Hi, I've got a kitten here. So the separator, this is the first parser. The separator is a space. And the parser that I want to apply is parse cell. And I'm going to apply that to the input data. And let's do at least a little bit of debugging here. Okay, that's not quite working. Oh yeah. Bail out early if the parse fails. Separated list 0 has not been included. Okay, I get the picture. Let's come up here. Oh, here we go. Here we go. Got her. Hi. Nom multi separated list 0. I need my keyboard. It is angry right here because I am returning something of the wrong type. It expects a result with vec option car, and it found vec option car. What? Oh, right. Back up here on this line, I return the error, and so I just have the bare result. I still have to return an OK. All right, let's see if this works. Parse crate row. I'm going to say we can match this one multiple times. We'll go with many 0. let's see what we get from the test code. Awesome, here we go. So, 3 lines of printouts. Oh. Conveniently, there is extra space along the end of this line. So each one of these lines is occurring right here. And then this line, the top level, is the list of all of these rows put together. And that is everything that I expect right now. So, finally, like an hour in, and we're finally done just with that parser. Just for good measure, let's go ahead and grab... Well, I know that the instruction parser is going to be pretty easy. Let's grab this row. Parse crate numbers, or no, parse stack numbers. And for this one, the end result, the only thing I care about here is a count, the count of the number of stacks. I don't actually care about any of the particular stack numbers. So let's grab a usize. So this row, it's going to be a bunch of numbers separated by spaces. So not separated pair, separated list 0. And shall I? Yeah, I'm going to force it to match at least once. So the separator is a space, and the actual data is a digit. There was a digit function somewhere in there, complete digit 1. Yeah, recognize one or more ASCII numerical characters 0 through 9. Oh, wait, but there's also just like a U32 parser, or a U8 parser. So we'll do U8. We'll import it from, that didn't work. Import it from complete. Perfect. And now I'm actually going to capture this because I'm going to do some extra transformations on the data. So input crate numbers. It's not even crate numbers. It's like the crate number row. Wow, what is this actually going to be? I don't actually know what the return type from this is going to be. I don't even know that this is going to work. Let's see what we get. So after that, let's do a separated list I have not included yet. Just gonna unwrap this one. Okay, so this is confused. The expression has a type of result vec8, string vec8. Expected result found a tuple. If we terminate the line correctly, we get an error. Okay, so this parse doesn't actually work because there's going to be these separators Actually, that's kind of weird. Can I just separate by generic white space? Space 1, maybe? One or more spaces and tabs. Yep. Yes, I can. Let's import that. Huh, why doesn't it like that? Cannot infer the type parameter of E because I am unwrapping it now. The type has to be known. Interesting. Parse any number of spaces greater than 1, then parse a U8. What do I get here? Stack numbers is empty. That's not what I thought I would get, actually. Because what I have is one row that has a whole bunch of numbers where each number is separated by, in practice, 3 spaces, but it can be an arbitrary number of spaces. So that's why it's a little weird to me. Maybe separated list 1 doesn't do what I think. Alternates between the two, fails if the element parser does not produce at least one element. So it should be flipping between parser 1 and parser 2. So if we're applying this parser, ABC, vertical bar, ABC, I can't imagine that this is going to be the right answer here, but we're going to discard the leading space. Got to include that function. Weird. Okay, I didn't expect that. So that leading space was the problem. So got to strip the leading space off. It's optional. So with that done, I'm going to switch this over to U8. Make sure that that works. Perfect. Those are 3 numbers right here, the stack numbers. And so now, the only thing I want to return here, actually, is stack numbers dot length. Well, oh, right. I have to return input as well. Great. And Great. So it is getting that I've got 3 stacks. Not going to be using that for anything at the moment. The last one will be the easiest one. We're going to let input commands equals parse commands. Actually, we're going to do a many one terminated by a... Wait, where's my new line? Had an end of line 1 here. Yeah, terminated. Each one is terminated by a new line. I want to parse a command. Give the input data, .unwrap. Let's see here. So a command is, fortunately this one is so simple. A command is basically 3 strings with a couple of numbers interspersed. So we just chain together some pretty simple ones here. We throw away the first, which is going to be a tag of the word move with a space. Don't forget the space there. On input, we'll get all 3 of those done. So move, space from space, and then space to space. So that gets the 3 words, and then in between them, stack number equals, in this case, it should be a U8. We're going to do that 3 times. Stack number, or no, actually, the count, followed by source stack, followed by destination stack. These should not be U sizes, these should be U8s because those are easier to work with. And then okay, so each one of these parsers can fail. Got to make sure to return or to bail early. And got to make sure to explicitly say that this is okay and return all of the unparsed input. And still got a compile problem. Separated pair is not being used, but that's not it. A function with a similar name exists. Line 31, many1, and we'll call it many0. So the number of stacks worked, but then it failed here, didn't it? Failed at not implemented, line 36. Why did it? Oh, right. There's a blank line. Got to throw that blank line away. It needs a type annotation. Ooh, that's uncomfortable. Cannot infer the type error. Oh, I wanted to avoid ever having to say that. We'll come back to that. I'm just going to make that easier by writing a function that declares iResult, so I don't have to figure out what the parser error type is. I want to Okay, all of that is okay. Now, why is this failing? Got it. I'm going to be very uncreative in my naming there. In fact, I don't even care about that. There we go. And it still does not like, oh, there is a space on that blank line. Well, let's throw that away. We're still getting to unimplemented without printing out the commands. That's kind of weird, actually. I wonder if it's abort. It's weird that it would abort early. So this probably doesn't work. Oh, it does. Oh, move from 2 to 1. My test data, move 1 from 2 to 1. Why is it? Oh, I think I am having trouble with the new line at the end of the stacks. Yeah, I should be consuming the new line on this. Or I should be consuming the new line before. No, we're going to do it here. There's got to be a better way to express this, but I'm not sure what it is. There we go. Yeah, so we've got this line that's got all of the stack numbers. There's still space and a new line on the end. In fact, where I thought I was handling that right here, no, sorry. What I thought I was handling right here was the space, or was the new line in between the two rows, but in fact I was ending up handling the space in the new line at the end of the crate list. I don't think I've really done it the most elegant of ways, but it's going to get the job done here. Obviously, I've got the correct number of stacks. I've got all of the cells. This is really a matrix. And then I've got the command, or all of the commands. So given all of this, theoretically, if you wanted to, you could just solve the problem with the data in this form. What I'm going to want to do is transform this, like basically, if we view this as a matrix, I want to rotate it 90 degrees so that I've got something that looks like stacks. Like I want actual stacks here, not rows that represent the stacks. So that was something that I got stuck on a week ago. I did work out eventually how to handle that transformation, or at least I worked it out on paper. So let's create a new type. Call it matrix, vec car. Theoretically, I should abstract this, but whatever. I'm not going to do that in this stream or even while solving this problem. And for the matrix, I want to implement the rotate function. And the way I'm rotating it is clockwise. And for this, I wrote the solution down on paper. Here we go. This is actually easy. This is actually a little bit easier to do if I go ahead and pre-build some things. So new from a vec car. I'm going to make a self. Rows, usize. Columns, usize. And then the data, whatever. So when we create this, I assume that I'm being given a square of data. So let's see here. It's row, row, row. So rows equals data.len, calls equals, let's go over all of the data. Data.iter. Fold? Is that what I use? Yeah. Fold 0 cur max cur if row.len is greater than max, then we return row. Actually, no, there's a function that handles this. Maximum, I think. Yes, that is it. Max and row.len. Just so I make sure that I get the maximum number of columns that are in here. And so here I will create the matrix. So rows, calls, data. And it is angry with me at that line. There we go. Now, the rotate function. Okay. What I'm going to do is, let's see, the number of rows in the input will equal the number of columns in the output. The number of columns in the output equals the number of rows in the input. I'm going to go ahead and write that part down. Okay, now going over the 0 dot dot self dot rows. So we're going to populate the first row, then we'll populate the second row. I'm going to do this in more familiar C syntax here. For row IDX in 0 dot dot self dot rows, and then for call IDX in 0 dot dot self dot calls. Okay, good. I actually got that right here. Let mute data equals. Oh, this is inconvenient. I'm just going to push data onto the end. In fact, let mute row equals vec new. And then data.push row. And then right here is where the magic is going to happen. So row.push, the value that I want is from the input data. The row number is the number of rows minus the current column. And then the column is, what did I write down here? I think it's actually just the row. Cool. Okay, so I've got that. I'm going to leave the input alone. Actually, I'll turn it into a matrix because it's so easy to do. Wasn't actually returning any of the data here. Matrix new from rows. Yeah, badly named, but okay. And got to make sure the parser still works, because for all I know within the parser, the input data is going to get passed on to something else. Matrix new arguments are incorrect. Needs a vec car, and it's being given vec option car. Oh, what a pain. Fine. See what the tests are doing. They are exploding, but there's a reason for that. Changed my data type here. So the stacks are, stacks dot data 0, data 1, data 2, and it should still fail because this should be sum Oh, these are transformed stacks already. Huh. Lol. Good job. Let's go ahead and rotate them. 'Cause why not? So right here. And then rotate CW. Okay, good. Now we go back down to the tests. 145. What I'm expecting now is some... That looks about right. That's no longer a thing. It failed! The length is 3, but the index is 3 on line 45. Oh boy, howdy. 0, 0, number of rows. Oh. Okay, right. Because the number of rows is 3. I'm subtracting a 0, so I still get 3, but that is out of bounds, so I need to remove 1. I don't know what the row IDX is gonna do. It's probably okay, because it's starting at the beginning. Okay, okay. It can parse data, panicked, assertion failed, left, right, 149. Oh, sweet. I don't know why it's only parsing 3. Oh. Yeah. So, okay, it transformed the stacks. Now that actually gets me further than where I got on Monday. Probably in my next step for solving the problem, I'll get rid of the matrix data structure and just take the vectors as they are so that I can, first of all, filter out the nuns, because there's never going to be a none in the middle. Stacks don't work that way in gravity. So I would end up back with like this as the actual stacks that I'm working with. But I would do that just by pulling the data out of the matrix and then filtering the nuns out. And then it should be extremely easy just using push and pop operations to carry out each individual command. In fact, we'll take a look at Rust's vector. Here we go. That's the module. I want the vec itself. We got the push function. Yeah, here we go. Push and pop right next to each other in the documentation. Gonna read it to make sure. Appends to the back of a collection, removes the last element. Okay, perfect. These are just your basic stack operations. The commands right here, these are basic stack operations. Like if you're going to be moving 3 items from stack 1 to stack 3, remember that they are 1 indexed and your arrays are 0 indexed. So it would be moving from vec index 0 to vec index 2. And it's just 3 times you're going to pop from your source and push onto the destination. And that's really it. This is one of those weird cases where just parsing the data takes a long time. And I'm hoping that it seems unlikely, but that this problem will influence any of the future. But I'm really hoping that maybe it does, but maybe it won't. It might be that I put out all of this effort to solve this problem alone. A few years ago when we were doing the int code computer, there was a lot of parsing involved, and you just kept on building up. So it kind of like pretty good return on investment there when it came to effort. So this has been a long recording. I'm actually at an hour and a half, which I don't really ever want to do, but I want to keep these to an hour, but I didn't really feel good leaving everything at like, okay, well, I'm parsing the data, but I can't actually do anything with it. So thank you for sticking around. If you made it all the way to the end, I guess let me know what you think. And I will, as soon as I'm done with this, I'll actually push my solution up so that you can see what the solution looks like in the end. That is it. Thank you, and I'll see you again next Saturday.